When we're simplifying higher powers of I, we can actually figure out what really large powers of I are equal to in terms of just I, -1, -I, or 1, using the patterns that we've just discovered. So what we want to do anytime we have a problem like this, we're going to take the power and divide it by 4, and then the remainder, when we divide the power by 4, is going to give us the reduced power of I. If we end up with a remainder of 1, then that's just going to be equal to I. If we end up with a remainder of 2, it'll equal -1. A remainder of 3 will mean that it's equal to -I. And if we get a remainder of 0, that means it equals 1. Now, most of the time, you're going to be doing these probably with the very large powers of I on your calculator, dividing them by 4 and seeing what happens. When you do that, you've got to recognize what happens with the decimal expressions. When we divide something by 4, if it ends in 0.25, that means that we have a remainder of 1. If it ends in 0.5, that means we have a remainder of 2. If it ends in 0.75, that means we have a remainder of 3. And if it comes out even, that means that we have a remainder of 0. So let's look at the first example here. We're going to simplify I to the 105th power. So I'm going to pull out my calculator at this point in time. And, whoa, sorry about that. And I'm going to go ahead and take 105 and divide it by 4. And when I do that, it ends in 0.25. That means that I have a remainder of 1. And so I to the 105th is just going to be equal to I. Let's look at the next example here. I to the 46th power. I'm just going to take 46 and divide it by 4. That ends in 0.5, which means that if I divided 46 by 4, I'd have a remainder of 2. And so I to the 46th is going to just be equal to -1. And then lastly here, I to the 678th power. Holy smokes. So we're going to take 678 and divide it by 4. And when we do that, again, it ends in 0.5. So we've got a remainder of 2. And that means that this is going to be equal to -1.